Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a systems and mechanical engineer and as a theoretical physicist. Today's screencast, like most of mine, is about the reciprocal system and how it compares to other theories out there. Today we have an interesting topic: habitable planets and alien civilizations in the reciprocal system. This paper is in my software ebook, Existence and Interactions, a computational treatise of the reciprocal system, the true theory of everything. The software ebook contains two files, PDF of 711 pages and a PowerPoint file, 711 slides. Has thousands of equations, numerous diagrams, tables. It'll keep you busy for months. This particular topic is of interest to a great many people, so that's why we're going to do this paper and make it available on YouTube. So here we go. Abstract. The general public, which is probably one of you out there watching this, as well as the scientific community, has enormous interest in the question of extraterrestrial life in our universe. The reciprocal system provides the answers. Yes, there are numerous habitable planets and numerous extraterrestrial civilizations. Values are supplied for the variables of the well-known Drake equation for our Milky Way galaxy. Okay, introduction. The reciprocal system of physical theory is described in the books by Dewey B. Larson, such as Reference 1 and Reference 2. The theory leads to the conclusion that there are numerous planets in our universe and that many of these are inhabited by intelligent hominids quite like us. Now here's the nomenclature. These symbols are used in the Drake equation. F sub e is a fraction of intelligent civilizations that develop the ability and desire to communicate with other worlds. F sub I, the fraction of F sub I, the fraction of life-bearing planets on which intelligence emerges. F sub L, the fraction of suitable planets on which life actually appears. F sub P, the fraction of stars with planets. Capital L, longevity in years of each civilization in the communicative state. N, the number of civilizations in our side of the galaxy that are currently capable of communicating with other solar civilizations. See, presumably, we're not going to be able to get transmissions from the other side of the galaxy because the nucleus will block the communications. N sub stars, the number of stars in the Milky Way. Small n sub e, the number of planets per solar system with an environment suitable for life. And capital R sub star, rate per year at which new stars are formed on our side of the galaxy during the period when the solar system itself was born. Okay, section 1, habitable planets. Now, Larson, reference 1, pages 101, 102, states the case very clearly. By the way, Dewey B. Larson was the founder of the reciprocal system of theory. He was my mentor from 1965 until 1990, at the time of his death. He was by far the most intelligent, most logical individual I've ever worked with. Okay, so he says here, and I'm going to quote, "The contents of this chapter identify some of the factors that have a bearing on the question as to where planets are likely to exist. A question that excites a great deal of interest because it is a key element in any assessment of the possibility of the existence of life, particularly intelligent life, elsewhere in the universe. The B component of a binary system is either a star or planetary system, not both." By the way, the B component would be the white dwarf star or the planets. The A component is the regular star, originally a red giant. So supernova creates a red giant white dwarf pair or a red giant with planets. Okay, coming back to this. The B component of a binary system is either a star or a planetary system, not both. This eliminates all binary stars, and since all class 1 stars, that is those that haven't gone through a supernova explosion yet, that's class 1, are automatically excluded, it confines the possibility of planets to single class 2 stars, such as the Sun, or to single components of multiple systems, class 3 and higher. By the way, the class number is the number of the cycle. So, inasmuch as a long period of reasonably stable conditions is probably required for the development of life, certainly for the emergence of any of the higher forms of life, the Class C stars of the second and later cycles, and the stars high on the main sequence, all of which are subject to relatively rapid change, can also be crossed off the list. Okay, continuing with the quotation here. The wholesale exclusion of so many different classes of stars may seem to limit the possibility of the existence of extraterrestrial life very drastically. But in fact, these conspicuous and well-publicized stars constitute only a minor part of the total galactic population. The great majority of the stars of our galaxy are small and relatively cool stars in the lower sections of the main sequence. As we will see in Chapter 12, there's a lower limit to the mass of a white dwarf star, and when the B component of a system is below this limit, it cannot attain stellar status. This implies the existence of an immense number of planets among the smaller systems. Of course, there are requirements as to size, temperature, etc. that a planet must meet in order to be available as an abode for life. But there is a zone in each system within which a planet of an appropriate size is quite likely to meet the other requirements, since Bode's law, as revised and as I've explained in a previous YouTube video, is applicable to all systems in which the conditions are favorable for planet formation, i.e. the small systems. It is probable that all of these systems have at least one planet in the habitable zone. So, wow. Okay. And continuing with this lengthy quote, again, Doobie Larson was the founder of the reciprocal system, my mentor, and a super genius. Okay, continuing. The findings of this work thus increase the probability that there are a very large number of habitable planets, Earth-like planets, let us say, in our own galaxy, as well as in other spiral galaxies. There are few, if any, in the galaxies smaller than the spirals, that is, the small ellipticals and the smaller regulars, because they are composed almost entirely of Class 1 stars. You know, there's stars that haven't gone through a cycle yet. The situation in the giant spheroidals is not yet clear. There are multitudes of lower main sequence systems in these giants, and these can be expected to have the usual proportion of planetary systems. However, the intense activity that, as we will see later, is taking place in the interior zones of these giants no doubt rules out the existence of life, at least in general. By the way, these large spheroidal galaxies are essentially what our local group would be if all the galaxies of the local group would be combined into one giant galaxy, which is going to happen eventually, by the way. Okay, so whether enough of this activity carries over into the outer parts of these galaxies to exclude life in these areas as well as uncertain. The oldest of these giants are probably lifeless. As we'll find in Chapter 19, there's a strong X-ray emission from these mature galaxies, and this is probably lethal. So far as we know at present, however, there may be outlying regions in some of the younger galaxies of this class in which the conditions are just as favorable for life as in the spirals. Continuing the quote, in today's science fiction, where life in other worlds is a favorite motif, the habitations of the alien civilizations are identified with familiar names for reasons that are quite understandable. The thrilling action that the authors of these works describe takes place on planets that circle Sirius or Arcturus or some other well-known star. But according to our findings, few if any of these familiar stars are capable of having a habitable planet in orbit, and are also old enough to have developed complex forms of life. Sirius, for instance, has a white dwarf companion instead of a planetary system. Arcturus is a young Class C star. The astronomers do not make the mistake of identifying the environments of these stars as the abode of life, but they avoid it by making a different mistake. In selecting the target of their first systematic attempt at interplanetary communication, which is way back in 1974, they were misled by their current view of the evolutionary direction of the stars. This initial effort was directed at the globular cluster Messier 13, on the assumption that it is a very old structure in which the processes that lead to life have had ample time in which to operate. We now find that the globular clusters are relatively young structures which, aside from a few stray stars that have been picked up from the environment, are composed entirely of Class 1 stars. These cluster stars have not been through the explosion process, and therefore have no planetary companions at all. As matters now stand, the available information indicates that habitable planets are plentiful, but that the planets on which life probably exists are not located in any systems that we can call by name. The stars that they are orbiting are undistinguished, anonymous, and with few, if any exceptions, unseen stars of the lower main sequence. Wow, what a quote. All right, section 2, alien civilizations, and we're not done with quoting from Larson. And in reference to pages 92 and 93, he states the case very clearly. So we got another quote here. We know that intelligence is favorable to survival, and therefore we know that evolution will produce an intelligent organism if it can. We know that evolution can produce an intelligent biological organism under the conditions prevailing on the Earth, since it did so. And since these are, by definition, the same conditions that prevail on any Earth-like planet, evolution can and will produce intelligent organisms on these planets. Furthermore, all other Earth-like planets are, like the Earth itself, located in existence as a whole, and they are therefore subject to the same Sector 3 influences as human beings. And by the way, Sector 3 is the non-physical realm. It's beyond space-time. Okay, continuing with the quote. There has been some opposition to the current efforts to open up radio communication with the inhabitants of extraterrestrial abodes of life, if there are any within range, on the ground that these beings may be of a malevolent nature and capable of doing us harm of some kind if we establish contact. Our findings indicate that these fears are groundless. The Sector 3 influences have more control over some individuals than others. But there's no reason to believe that their average effectiveness in application to any other large group of intelligent beings is any less than it is in application to the human race. If the inhabitants of a distant planet are far enough advanced technologically to enter into communications with us, they are also far enough advanced ethically to constitute no more of a threat to the nations of the Earth than those nations are to each other. On the basis of the foregoing considerations, we can say that Homo sapiens is not unique. He's only one of many, a conclusion that has some very important implications for both science and religion. Wow, okay. Now let's get on to some equations here. Section 3, quantitative estimates by Shapley and Drake. Now, I'm going to quote from Larson a third time, this time reference to page 77. And Larson himself quotes Harlow Shapley's quantitative estimate. Harlow Shapley was, of course, a famous astronomer. Harlow Shapley has made an interesting calculation in this connection using figures which he considers very conservative. That is, figures which underestimate rather than overestimate the number of planets on which life exists. Assuming that only one star in 100 is a single star, that only in 100 of these has a system of planets, that only 1 in 100 of these systems includes an Earth-like planet, that only 1 in 100 of these Earth-like planets is neither too cold nor too hot, and that of them, only 1 in 100 has a chemical environment similar to ours. He says that, now quoting Shapley, we could still have, after all that eliminating, 10 billion planets suitable for organic life, something like that on Earth. All right. But nowadays, most scientists use the Drake equation rather than Harlow Shapley's estimate. So the Drake equation is n equals r sub star times f sub p times n sub e times f sub l times f sub I times f sub e times capital L, where n is the number of civilizations in our side of the galaxy that are currently capable of communicating with other solar systems. R sub star is the rate per year at which stars are being formed in the galaxy during the period when the solar system itself was born. F sub p, the fraction of stars with planets. N sub e, the number of planets per solar system within environments suitable for life. F sub l, the fraction of suitable planets on which life actually appears. And F sub I, the fraction of life-bearing planets on which intelligence emerges. Of course, F sub e is the fraction of intelligent societies that develop the ability and desire to communicate with other worlds, and L is the longevity in years of each civilization in the communicative state. Okay, I did give these symbols at the beginning of the presentation, but it was just, I think, worth repeating so there's no misunderstanding. Okay, now, the value of each of these variables is subject to a wide range of opinions, as can be seen by any of the many discussions on the World Wide Web. R sub star depends on the number of supernovae type 1 per year in the galaxy and the cycle class of the star. This could be from a class 1, 2, 3, 4, or even 5 star, but there are a few stars above 3 in our galaxy. Captured globular clusters, mature or immature, do not help because the stars of these clusters are pre-explosion, at least most of them. The existing stars of the galaxy accrete all the available interstellar dust, and so no new stars form between existing stars. An explosion of a class 2, 3, or above star could wipe out an existing solar system. A conventional estimate for R sub star is 7, but this seems way too high, in my opinion. It's more likely to be much smaller, say about 0.01. That is one net new solar system per 100 years in our side of the galaxy. So I'm going to use R star equals 0.01 new stars per year from a supernova explosion. Now, the next variable, f sub p, the fraction of stars with planets, is easier to estimate. Either a class 2 or higher class star is binary or has planets in our local environment. It's clear that approximately half of the stars are binary. The other half of class 2 or higher class stars must therefore have planets. So this one's easy. F sub p is equal to 0.5. The next variable, n sub e, the number of planets per solar system with an environment suitable for life, is also fairly easy to estimate. It's probably between 1 and 2, and so 1.5 seems approximately right. Let's look at the Earth and Mars. Anyway, so 1.5 is a good guess. The next variable, n sub l, is fraction of planets, suitable planets on which life actually appears, is almost assuredly close to 1 because life appears to be remarkably hardy, I should say. F sub l equals 1. The next variable, and I guess I used a capital L there instead of small, but oh well, whatever. The next variable, n sub I, the fraction of life-bearing planets on which intelligence emerges, is almost assuredly close to 1 because biological evolution produces it. So that's 1 as well. We have just seen that all intelligent hominids in our galaxy are as curious about alien civilization as we are, and so F sub E will also be set to 1. It takes approximately 5 billion years for an intelligent civilization to evolve, and since a given star cycle lasts approximately 10 billion years, this leaves 5 billion years as the maximum lifetime for a civilization. However, the last 3 billion years, when the star is high up on the main sequence, may make it difficult for civilization to survive, and so the net maximum amount of time would probably be about 2 billion years. L equals 2 billion years. Putting all this together, we have n equals to 1.5 times 10 to the 7th. 15 million planets with intelligent civilizations on our side of the galaxy. An estimate in Wikipedia reference 3 gives 3.64 times 10 to the 7th, or about twice ours, which should be the total for the galaxy. Given that there are roughly 300 billion galaxies in our universe, of which perhaps 1/3 are spirals, this implies that there are n times 300 billion times 1/3 equals 1.5 times 10 to the 18th intelligent civilizations in the universe. And that is a staggering number. The giant spheroidal galaxies are probably devoid of life, as I quoted Larson previously, except at the edges, and the small elliptical galaxies and globular cluster stars are mostly comprised of class 1 stars, so this leaves spiral galaxies as having most of the intelligent life. Given that there are 200 billion stars in our galaxy, this means that n sub stars equals 200 billion here, and then n divided by n sub stars, 7.5 to the 10 of my stars of our galaxy have intelligent life. SETI has searched fewer than 20,000 star systems to date. Thankfully, they are now looking at red dwarf stars on the lower main sequence, where the reciprocal system says there should be planets. Alright, now section 4, travel to or from alien civilizations. Well, this is a very dubious proposition, despite all the UFO channels on YouTube. In the reciprocal system, space-time cannot be, quote, warped, and so warp drive is not feasible. The maximum one-dimensional speed in space is c, the speed of light, and that's the unit speed in the reciprocal system. Given that the reciprocal system is a perfectly symmetrical theory, there are as many speeds above unity as there are below. But the speeds above unity are in time. This means that the velocity equation v equals s over t is flipped to v equals t over s. Outward in coordinate time is equivalent to inward in coordinate space, so the speeds above c mean that the objects get closer together, not further apart in space. So all those supposed engineering designs for faster than light travel are destined to fail miserably. Sorry, Star Trek fans. I love Star Trek, but it's dead wrong scientifically. So the above conclusion explains the Fermi paradox. If there's so many alien civilizations out there, why cannot we see them or find them? Where are they? The answer is that we're all trapped in our solar systems. The probability of being able to leave the solar system and travel to another in a reasonable amount of time with a reasonable amount of resources is slim to none. Faster than light travel is impossible for us, and it's still impossible for a civilization even 2 billion years more advanced than us. Alright, well that's my conclusion. Now, we might be able to send real tiny little probes with sufficient resources to travel to some nearby star, send back radio communications to us. That might be possible. But anything really large, anything large enough to carry human beings, would consume too many resources and take too long. Anyway, that's the conclusion of the reciprocal system. It's scientific. And I just want to say the references here: Dewey B. Larson, The Universe of Motion, that's his astrophysical masterpiece, and also his metaphysical work, Beyond Space and Time. And of course, the reference to Wikipedia and their version of the values for the Drake equation. Well, I hope you enjoyed that presentation. I know this is an extremely popular topic on YouTube. And so now you know what the reciprocal system says about it. Now, for the simplest possible treatment of the reciprocal system, you can obtain my work, The Unmysterious Universe. Just the concepts, very little mathematics, all the diagrams you need. And you'll be able to grasp the theory quickly. If you do want all the mathematics, then of course get my magnum opus. The paper I just read is in there. Existence and Interactions, a computational treatise of the reciprocal system, the true theory of everything. Again, 711 pages in the PDF, 711 slides in the PowerPoint file. And I just gave you a taste of one of the chapters in there. Okay, and once you get through that, then you can consider getting the 2 database modules, System Microcosmos Database, which covers all the properties of subatoms, atoms, photons, compounds, and alloys, both material and cosmic. And the Reciprocal System Macrocosmos Database, which covers all the astrophysical properties of the universe, including the universe as a whole, including discussion about aliens like in here, including galaxy clusters, galaxies, star clusters, stars, planets, moons, minor bodies like asteroids and comets, nebulae, and voids. The 2 modules together cover all the major topics in physical science. You can use it in your scientific engineering practice. There's nothing like it in the entire world. Okay, guys and gals, thanks for your attention today. And again, study the reciprocal system and prove it for yourself.